Welcome again. Today we are starting new lesson in the geometry. That means name of the lesson is a circle. It is very important lesson for the geometry purpose. First lesson you see, that means similarity. Second lesson, that is the Pythagoras theorem, and third lesson, that is the circle. These three lessons are very important because of why too much theorem. That means in first lesson there are 3-4 theorems, in second lesson Pythagoras there are 2-3 theorems, and now in the circles approximately 10 to 12 theorems are present. Okay, and regarding with these theorems, some problems are asked to you in the exams. Also write down the theorems for 4-5 marks, or also solve the theorems as per given. The what we say, complete the filling the blanks of the theorem. So for that purpose these three lessons are very important, and this is a very easy lessons, but in these lessons 3-5 exercises are there. So I make a 5 part of these lessons of the circle. First part, second part, third part, fourth part and fifth part. You see 5 videos of these lessons. That means as per exercise I create the videos. Okay, let's see which are contains in this lesson. That means circle passing through the 1, 2, 3 points, then circle touching to each other, inscribed angle, intercepted arc, secant tangent angle theorem, secant and tangent, arc of the circle, cyclic quadrilateral, and theorem of intersecting chords. Okay, then mean in previous year, that means in last standard, that in the 9th standard you see congruent circles. What is the congruent circles? The circles having a same radius, then these two circles are said to be congruent circles. Okay, then concentric circles, two circles having one center, two circles having only one center, at that time two circles are said to be concentric circles. And intersecting circles, that means two circles intersects each other at 2 points. That means two circles intersecting 2 different points, then these two circles are said to be intersecting circle. Okay, that with these three concepts, that means congruent circles, concentric circles and intersecting circles. Okay, then you are familiar with the concept like a center, radius, diameter, chord, interior and exterior of the circle. That means congruent circle, concentric circle, intersecting circle. These concepts you are familiar. Okay, you know all these things in previous standard, that means in 9th standards. Okay, then we see some properties of a chord studied in a previous standard. Which properties? These properties are, which are these properties? These properties are, okay, some properties of the chord and concept of circle, that is a set of points from equidistance from a fixed point in the plane, that is called a circle. What is a radius, what is a diameter, what is a chord. Then some properties. First properties, perpendicular drawn from the center of the circle, perpendicular drawn from the center of the circle on its chord bisect the chord. Perpendicular drawn from the center of the circle on its chord bisect the chord. Second property, segment joining center of the circle and midpoint of the chord is perpendicular to the chord. Third property, congruent chords of the circles are equidistant from the center of the circles. Chords of the circle equidistant from the center of circles are congruent. There are 3-4 properties of this. Okay, or you know, I repeat it again, which are properties of a chord we studied in previous standard. Which property? From the center of, if we draw if we draw perpendicular from the center of the circle to the chord of the to its chord, then it bisect the chord. If we draw a perpendicular from the center of circle to its chord, bisect the chord. This is the first property. Then segment joining center of the circle and midpoint of the chord, these are perpendicular to the chords. Congruent chords of the circles are equidistant and from the center of the circle, and congruent chords of the circle equidistant from the center of circles are congruent. These are 4-5 that is properties of the circles we studied in the previous standards. Okay, then next point of this, that means circle passing through the 1 point, 2 point, 3 points like this. Which are these? Okay, infinite circle passing through the 1 points. Okay, let's see clear all these on the board.
Start.
Infinite circles are passing through the 1 point. Infinite circles passing through the 2 distinct points. There is a unique circle passing through the non-collinear points. No circle can pass through the 3 collinear points. These are major points. I repeat it again. Infinite circles passing through the 1 point. Infinite circle pass through the 2 distinct points. There is a unique circle passing through the 3 non-collinear points, and no circle passing through the collinear points. 3 collinear points, no circle passing through the 3 collinear points. Okay, now next point of this lesson, that is the secant and tangent. The concept of secant and tangents. Okay, what is a secant and what is a tangent? First of all, we clear all these concepts and then go ahead what is a secant and the tangent. Okay, starting with a secant and tangent. That means their tangent at any point of a circle is perpendicular to the radius at the point of contact. There is an indirect proof. That means 2 concepts, that is a theorem of this, and then we are going to solve some problems of tangent secant theorem. Okay, first of all, we clear the concept of these. That is what is a tangent, what is a secant. That means in previous standards we clear the concept regarding with the circle. Don't go on my drawing. Huh? This is the center of the circle O. This is OA is the radius. Okay, and also OAB is the diameter. Okay, and this is a chord. Okay, that is chord, C-H-O-R-D, chord. This is OA, that is the radius, and BA, that is a diameter, and O is the center of the circle. Okay, you can draw so many radius from the center of the circle. Okay, now we see these concepts in the previous standards. Also we see a congruent circles. Congruent circles means what? Circles having same radius, OA and PQ, 2 cm, 2 cm. Then 2 circles are congruent, concentric circles. Okay, this is a concentric circle, and this is a intersected circle. That means this is P and this is Q. A, that point A, and that point B. That means concentric, congruent circles, concentric circles, and that means which we say intersected circles. These concepts we see in the previous standards. Also we see that some properties of the chord, that are properties of the chord a perpendicular drawn. Suppose this is a circle. Okay, don't go on my diagrams. My diagram is not good, but I try to solve. Okay, this is a circle. O is the center. A perpendicular drawn from the center of the circle to its chord bisect the chord. Suppose this is a chord A and B. The first property of the chord, perpendicular drawn from the center of circle to its chord. Suppose we are drawing a perpendicular drawn perpendicular to chord AB. So if we draw a perpendicular from the center of circle to its chord, bisect the chord. That means here it bisect the chord. AM and BM, two parts are there. That means bisect two equal parts, make two equal parts of the chord. This is the first property of the chord we see in this property. Then second property is that the segments joining center of circles and midpoint of the chord is perpendicular to the chord. Segment joining center of the chord. That means suppose if O is the center of the circle, M is the midpoint of the chord, then suppose this is an, we change the names. This is an P and this is an Q. Okay, then OM perpendicular to chord PQ, therefore OMP and OMQ both are 90 degrees. That means this is a segment. OM is a segment joining center of the circle and midpoint of the chord. Segment OM is the segment. Suppose this is an O and M. What I say, understand. OM is the segment. The segment joining center of the circle and midpoint of the chord is perpendicular to the center of the circle. That is the perpendicular chord. This is a perpendicular chord. This is the second property of the chord. Third property is that means suppose this is a circle. Okay, then this is an O. Sorry, I draw clear somewhat mistakes when drawing the. My drawing is not perfect, but I try to clear this. Okay, this is a circle with a center O. Congruent chord. Suppose this is a chord and this is a chord. Okay, AB and CD. Suppose this is A and this is B, this is C and this is D. Congruent chords. Okay, congruent chords are equidistant. This is and this is chord. These two chords are equidistant from the center of the circle. Congruent chords are equidistant from the center of the circle. Okay, this is M and this is M. Congruent chords are equidistant from the center of the circle. This is the third property of the chords. And fourth property, chords of circles equidistant from the centers are congruent. That means this is an congruent. These two chords are congruent. Equidistant chords are congruent. This is a fourth property which we learned in the previous standards. Now next, that means in this year we clear the concept of tangent, secant. Okay, let's see. I draw three figures. Okay, from which you can understand very easy. Look at these three diagrams. First, second and third. That means this is the first diagram, this is second diagram and this is the third diagram. Okay, In first diagram, what we see in the first diagram, circle, not a single point is common in circle and the line L. A circle with the center A and line L, there is no common point between two. So, okay, and the circle with the center B here, in which in second diagram center of the circle is B and line N, in which point P is a common point between them. That means P is common on both line M and the circle with the center B. Hence, line M is called as a tangent. Then P only one point. What I see, listen very carefully. When circle and line, circle and joining line have only one point common, then the point is called as a tangent, or line is called as a line M is a tangent of the circle, and point P is called as a point of contact. Line M is a tangent and point P is a point of contact in the second figure. And in third figure, what we see here, Q and R both are common points between which are lie on the line and the circle. Okay, therefore Q and R intersecting points of a line N and the circle N, so it is called as a secant of the circle. So line N is the secant of the circle, line M is a tangent of the circle. What is the difference? Tangent, the point of circle, point of contact of the circle and line, that is called a tangent. Only one point is common between circle and the line, and in secant 2 points are common, that means in circle and in the line. That is here this diagram, second diagram, here N is tangent and P is point of contact. Here N is secant, okay, N is, what do I say, secant, okay. And let's understand the property of a tangent, okay. From this we clear that tangent at any point of the circle is perpendicular to the radius of that point. From this, what we learn? From this we learn, okay, are you understand this concept? Now, what is the concept of the tangent? Okay, I draw another diagram. From this you can understand it very easy way.
Start.
Look at the figure. From these three diagrams we clear that the tangent at any point of the circle is perpendicular to the radius of that circle. Suppose we draw a tangent like this. That means here one point is circle. Suppose we draw tangent here, like this here, like this here, like this here, like this here, 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 also here. Whenever we draw a tangent, that means it is a perpendicular to the center of the circle. Whenever you draw, this is the center of the circle, point O. That means from this second diagram we see a tangent at any point. Suppose tangent at this point, tangent at this point, tangent at this point, tangent at this point, this point, this point. Tangent of any point of the circle is perpendicular radius at that point. This property is known as a tangent theorem. If we draw tangent at any point on the circle, it is perpendicular to its radius. It is perpendicular to its radius. This property is called as a tangent theorem. Whenever we draw a tangent at any point of the circle, it is perpendicular to its circle. It is perpendicular to its radius. Here the radius we give the name A, B, C, D, E, F. All these are radius. OA, OB, OC, OD, OE, OF, these are radius. And we draw a tangent, it is a perpendicular to its radius. This property is called as a tangent theorem. Okay, let's see the theorem regarding with this. A tangent at any point, tangent at any point of a circle is perpendicular to the radius at that point, to the radius at the point of contact, at the point of contact. Okay, there is an indirect proof of this theorem. Okay, given. What is given? Line L is a tangent to the circle. Line L is tangent to the circle with center O. With center O and point of contact A. Okay. Prove. What is to prove? What is to prove? Line L perpendicular. Line L perpendicular OA. Radius OA. Sorry. Perpendicular radius OA. Perpendicular to radius OA. Okay. Suppose this is a diagram. Here we diagram, shortly diagram I draw. Let's. This is a circle and this is line L and this is O and point of contact E. Okay, and this is this. Given line L is a tangent to the circle with the center O and point of contact A. Prove line L perpendicular to radius OA. This is to prove. Okay. Assume that. Proof. What is that? Assume. Assume that line L is not perpendicular to OA. Line L not perpendicular to segment OA or radius OA. It is not perpendicular. And now we draw, suppose segment OB is drawn. Here we draw another lines on this OB, OC and OE. Okay, and this is line L. Okay, assume that line L is not perpendicular. We are considering that L is not perpendicular to OA. Okay, and then what happens? Suppose OB is drawn. Suppose OB is drawn. Right?
Start.
Suppose OB is drawn perpendicular to line L. OB is drawn. What I say, listen carefully. Assume that line L is not perpendicular to segment OA. Suppose OB is drawn perpendicular to line L. Okay, of course B is not same as O. Of course B is not as same A. B is not same as A. B is not as same as A. Okay. Now take a point C on the line L. Now take point C on line L. We are taking point C on the line L. Okay, such that ABC. Therefore, what happens such that ABC collinear ABC. These are in one line points. Okay, therefore BA is equal to BC. BA is equal to BC. They are collinear points. So therefore BA is equal to BC. Okay. Now triangle OBC and OBA. Two triangles are formed. OBC, OBA. Okay. Two triangles are formed. Now in triangle OBC and triangle OBA. Look at figure. OBC, OBA. Two triangles are formed. Okay. Segment BC congruent segment BA. BC congruent BA. Segment BC congruent segment BA. Okay. Segment BC congruent segment BA, that is by construction. Okay. Then angle OBC. Angle OBC congruent angle OBA. Why? Each is right angle. Each right angle. Okay. OB congruent OB. OB congruent OB, common side. Okay. Therefore triangle OBC congruent triangle OBA by SAS test. Look at here. BCBA, this side congruent. Okay. Then OBC congruent OBA, OBC OBA, both are 90 degree. That means right angle triangle. OB congruent OB, that is a common side. Side angle side. This side, angle, this angle, and this is common side. Therefore, OB is equal to OB, common side. SAS test. Two triangles are congruent. Okay. Also, OC is equal to OC. Therefore, OC is equal to OA. I write here O. OC is equal to OA. Clear? But OA is a radius. But segment OA is a radius. Segment OA is radius. OA is a radius. Okay. OC must be radius. Therefore, segment OC must be radius. Okay. C lies on the circle. Therefore, C,
Start.
that means segment, but segment O is a radius. Also, segment OC must be radius. C lies on the circle. Okay, that means line L intersects circle in two distinct points. Line L intersects intersects circle into two points. Okay, A and C, two distinct points. Sorry, 2 points, two distinct points. I am writing here two distinct points. Two distinct points. Which are these? A and C. Circle, that means line L intersected the circle into two distinct points A and C. But line L is a tangent. But line L is tangent. Okay, that means it is a given. In the right here, line L is a tangent. Is given. Therefore, it intersects circle in only one point. Therefore, it intersects only in one point. In previous, we see tangent intersects only in one point. Therefore, our assumption is that L is not perpendicular to radius OA is wrong. Therefore, our assumption, what we assume, line is not perpendicular. Our assumption, line L, that line L is not perpendicular, to radius OA, to radius OA is wrong. Therefore, line L perpendicular to OA. This is a proof. Any problem you may ask me. Tangent at any point of the circle is perpendicular to radius at that point of a contact. Line L is a tangent to the circle with a center O at point of contact A. What is to prove line L perpendicular to radius OA? What is then proof? We have assumed that line L is not perpendicular to segment OA. We have assumed that. Then we have drawn another. Suppose OB is drawn perpendicular to the line L. Of course, B is not a same A. Now take a point C on the line L such that ABC are collinear. BA is equal to BC. BA is equal to BC.
Start.
BA is equal to BC. Now in triangle OBC and OBA, segment BC congruent segment BA by construction. Angle OBC congruent OBA, each right angle, and OB congruent OB, that is a common side. Therefore, triangle OBC congruent OBA as test, angle side test. Therefore, OC is equal to OA, but segment OA is radius. Therefore, segment OC must be radius. Therefore, C lies on the circle. That means line L intersects circle into two distinct points A and C, but line L is a tangent, that is a given. Okay, but line L is a tangent, that is given, therefore it intersects only one point. Our assumption is that line L is not perpendicular to radius OA is wrong. Therefore, line L is perpendicular to OA. This is the first theorem regarding with the tangent. This is called the tangent theorem. Okay, are you good?